degrees. And now the B part, when the block is sliding down with uniform velocity, what will be the angle? So when the block slides down the incline at a constant velocity, let the angle be alpha. Will that angle alpha be, will that angle be greater or smaller than the angle we calculated earlier? Will be smaller, because to keep the object moving uniformly, you need only a less amount of force. That means the angle can now be smaller, and let that angle be alpha. The net force on the block now is 0. That means the force of friction Fk, the force of friction now is no longer Fs, but it is Fk, which is less than Fs. And that's the reason why the downward force now need only to be less than the previous case. And that's the reason why the angle can now be smaller. So Fk equal to mu k mg cos alpha, mu k times 49 cos alpha. That is the force now acting up the plane. And that force equal to 49 sine alpha. And that is when the forces are balanced, and that is when the object will be moving with uniform velocity. Now, solving from mu k gives you mu k equal to tangent of that angle. So alpha will be therefore tan inverse of mu k. Alpha is tan inverse of 0.4, that is 21.8 degrees. So if when the angle is 30 degrees, the block begins to slide down. In order to keep it moving with a uniform speed, you can decrease the angle to 21.8 degrees. Okay, let's now look at another problem. While being unloaded from an airplane, a 20-kilogram suitcase is placed on a ramp inclined at 37 degrees. When released from rest, the suitcase accelerates down the ramp at 0.25 meter per second squared. What is the coefficient of kinetic friction between the suitcase and the ramp? Well, we have now an inclined plane again, so let's make a picture of that. This is a suitcase on the ramp inclined at an angle of 37 degrees. The mass of the suitcase is 20 kilograms. That means its weight will be 20 times 9.8, 196 Newton acting vertically down. Now always do these preliminary steps, because the more number of times you do it, the better you learn these concepts. So mg equal to 196 Newton acts vertically down on the suitcase. The force pulling the case down the ramp, the force pulling the case down the ramp will be mg sine 37. That is 196 sine 37. That is 118 Newton. So the force that is pulling the suitcase down the ramp is 118 Newton. What is the force of friction? Since the suitcase is sliding down, the force of friction is the force of kinetic friction. So Fk equal to mu k mg cos theta. Alright? Fk equal to mu k mg cos 37 degrees, and that will be mu k times 196 cos 37. We don't know mu k, do we? No. Therefore, we will leave it as it is, and 196 cos 37 is 156.5. So the frictional force Fk equal to 156.5 mu k, and that will be opposing the downward motion of the suitcase. That will be the upward force. Fk equal to 156.5 mu k. Therefore, what is the net force on the suitcase? The net force on the suitcase is the downward force 118 minus the frictional force 156 mu k. And it is this net force that produces this acceleration on the suitcase of mass 20 kilogram. So we can now say the net force equal to ma. Alright, let's do that. F net equal to ma, and that is 118 minus 156 mu k. This is F net equal to ma, mass is 20 kilogram, acceleration is 0.25, and this 20 multiplied by 0.25 is 5. So our equation now is 118 minus 156 mu k equal to 5, and the only unknown there is mu k, which you can calculate. So 156 mu k equal to, take it to the right side, will be 118 minus 5, that is 113. Therefore mu k is 113 divided by 156, that is 0.72. That is the coefficient of kinetic friction between the suitcase and the ram. Alright, let's now do another problem. A 3 kilogram box resting on a horizontal shelf is attached to a 2 kilogram box by a light string as in the figure. There you are. A 3 kilogram box sitting on a horizontal shelf is attached to a 2 kilogram box by a light string that passes over a pulley. What is the minimum coefficient of static friction such that the objects remain at rest? In fact, what is the coefficient of friction between the surfaces such that the frictional force opposing motion will be exactly balancing the tension force pulling the object to the right? That is what we need to find. You know that the frictional force will be the frictional force will be, what is that? Fs. Force static friction will be mu s Fn. Is that right? Alright, let's write that down. Well, let's consider the forces on the 3 kilogram box. What are the forces on the 3 kilogram box? Now, the weight of the box mg equal to 29.4 will be acting vertically down. And the normal force Fn will be acting vertically up. Now, they cancel each other. They really don't play a role in the motion of that box, does it? No. But you need them because we need the normal force to calculate the frictional force. So, the two vertical forces acting on the box are the weight 29.4 acting vertically down, and the normal force Fn, which is equal to 29.4. The tension T on the string will be pulling the box to the right. So here is the tension T that is pulling the box to the right, and what other force is there on the box? The other force is the force of friction. The force of static friction to the left such that Fs equal to mu s Fn. And you know the value of Fn. Fn is 29.4. So that Fs equal to mu s Fn, that is 29.4 times mu s. We need to find the minimum value of this mu s. Well, mu s has a minimum value when the forces acting on that object are balanced. The force acting to the right, which is the tension force, is balanced by the force acting opposite to that, which is the force of static friction, 29.4 mu s. Okay. Now, the minimum value of mu s should produce enough frictional force to the left to balance that tension force. Is that right? So, the value of mu will be minimum under this condition. Under what condition? T minus Fs equal to 0 or T equal to Fs. So, Fs in that state will be equal to T, or 29.4 mu s equal to T. Now, there are two unknown quantities there, so we will leave it there as equation 1. Well, we need another equation to solve that. Where are we going to get that equation from? Well, that equation is going to be obtained by considering the forces on the 2 kilogram. Let's now consider the forces acting on the 2 kilogram mass. Can you tell me what those forces are? Well, the weight of the 2 kilogram will be acting vertically down, and the tension will be acting vertically up. And because the pulley is frictionless and the same string passes over it, the tension forces will be the same. Is that right? The weight of the 2 kilogram, 2 times 9.8 is 19.6, is acting down over here. The tension T on the string will be acting vertically up. There is the tension T acting vertically up. And now, when the system is balanced, it is not moving yet. That means the system is balanced. Now, when the forces on this are balanced, 19.6 Newton must be equal to T. Is that right? Since the system is not accelerating, these two forces must be balanced, or we have T minus 19.6 equal to 0, or T equal to 19.6. Well, once you have the value of T, you can now take it to the equation 1 and calculate the value of mu s. So using this value of T in equation 1, we have 29.4 mu s equal to T, which is 19.6. Therefore, what is mu s? Mu s is 19.6 divided by 29.4, that is 0.68. Okay.